So this question is a small bit harder. So again, if you want to attempt it, it's 2024 paper 1 question 7. So here we have a function which models the number of bacteria in a dish with time. So here t is time and p of t is the number of bacteria in thousands and time is in hours. So we're told first of all to complete the table. So we can do that using the table function on our calculators, or we can just sub it into our calculators. I'll just do that with this because I know a lot of you have different calculators with different calculator functions, so I think it'll be easier if I just sub it in individually. So for the first one, we're told the time is 0, so instead of t, we put in 0. So it's 0 cubed minus 6 times 0 squared plus 6 times 0 plus 20. That gives me 20 as my answer. Then we just go back to this and we put in 1 instead of 0. And we see my answer is 21. Then we might as well double check the answer there, even though it's given up to us. Yep, so 16 is what we expected to get because it's here, and 16 is what we got in our calculator. So that tells me that I'm on the right tracks. Let's see what we get for 3. It's 11. We're going to trust the answer they gave us for 4, and we're just going to put in 5 now. And we get 25 as my answer. So we have our table, and the next thing it tells us is to draw the graph of P of t on the axes below. So one thing we struggle on as a class is labeling our axes and having them evenly spaced. Thankfully, 9 times out of 10, you actually won't have to draw your own axes. They'll be given to you in the question, so it's not the biggest issue. So our first point is 0, 20. So we go to 0 on the x-axis, 20 on the y-axis, and it's going to be here. Because we put my inputs on the x-axis and my outputs on the y-axis, which is labeled first. The next one we go to is 121. So 1 is here, 21 is there. Sorry, I should have actually drawn it down here because it goes up in twos. So I might ignore this small black dot and go with this one. Next point is 216, which is here. 311 here, 412, and 525 is up here. So now we're drawing that graph. We need to connect the lines as best as we can. So it looks something like that. This should kind of be a bit curved that way instead, but that's great. So now it's asking us questions on it. So these 3 questions are all calculus, so we don't have to worry about them for now. So now part B of this question gives us a different function, and this function is 300 multiplied by 2.72 to the power of 0.5t. So this is what we call an exponential function. And we haven't actually worked with those before, but the technique for working them isn't any different, so I expect you to be able to answer them. So the first one, t is still time after hours, and it's telling us to find what k of t is after 1 hour. So if k of t is after 1 hour, then my value for t is going to be 1. So all we do is put into our calculator exactly like this, 300 by 2.72 to the power of 0.5 times 1. So that would be 3,000, multiplied by 2.72 to the power of 0.5 times 1. That gives me an answer 4,948 because it says correct nearest whole number. So the next thing is after 2 hours. So we go back to our original equation and we just replace 1 with 2. My answer then 8,160. last thing we need to do, after n hours, there are at least 35,000 bacteria according to K of t, where n is a natural number, so that just means it's a whole number. By continuing the pattern above, or otherwise find the smallest possible value of n. So this question comes down to indices, so we're not going to worry about it now. All you need to know for now, is that you would let this function, you know, K of t is going to be equal to 35,000, so we would let this function equal to 35,000 and try to solve it from there. So to solve that, we do need indices, which we'll be going over soon enough, but for now I'm happy if you can get to this step.